On example 13, find the limit as x approaches 0 of, and we have this a very scary looking complex fraction, 1 over x plus 3 minus 1/3, all of that divided by x. So just like we've seen in all the other examples, the very first thing that we always try is a direct substitution and see what happens. And based on that direct substitution, whatever it is that we get, that's going to help us figure out what we're supposed to do next for this particular limit. So if I plug in a 0 across the top, I would get a 0 plus 3 on the bottom, which is a 3. I get 1/3 minus 1/3. Looking familiar here, and a 0 on the bottom. Yep, pretty sure that's 0 over 0. Indeterminate form. That's a whole. So my strategy, or my goal, I should say, is to find a function that agrees with this one everywhere except for at this hole that's right here. And how I do that, well, let's look to see what we've done so far, and let's see if any of those strategies apply. So the one right before that was rationalizing the numerator with some sort of conjugate. Well, there's no square roots in this one, and it makes sense, right? Okay, so now that's not very helpful. Let's see, on this one, what we did is we expanded out all our terms, and then we combined some like terms. We did some simplification, and voila, it resolved our whole for us. Well, there's nothing to really expand out here. That strategy doesn't seem to apply either. And then let's see, what was the first one that we did? Oh, that's right, we factored and we canceled out some common factors. Okay, let's see. Let's see. Oh, yeah, all of those things are listed right there, right? They're all listed right there in green. And, well, it doesn't look like there's anything that we could factor here. Well, let me ask you this. When you're in Algebra 2 and you first learned to deal with these complex fractions, what did you do? I think what you did was you multiplied by the least common denominator, and that resolved your complex fraction. We're going to do the same thing here. And specifically, when I get a least common denominator, it's just the stuff across the numerator. That's right there. The x that's in the bottom, we're not going to put that as part of our least common denominator. We could, but it would just complicate this. We only need to consider the stuff across the top. So let's watch what happens when we do this. So we limit as x approaches 0, 1 over x plus 3. I don't know what that was. Plus 3 minus 1/3 over x. So notice that our denominators here are completely different. And so the common denominator, the least common denominator, is just the product of those two things. So I'm going to multiply by 3 times x plus 3. And that's not a fancy one just yet, but now it is. When I multiply that by that fancy one, we're just going to rearrange some things. It's still going to be equivalent, as we will verify in a graph here at the end of this thing. So when I go to distribute here, which is basically what I have to do, I have to multiply this 3 times x plus 3 times both of these things. And since that can get kind of complicated, I'm going to write out those steps explicitly. If you're comfortable with the algebra right here, you do not have to do that. You're under no obligation. So I'm going to multiply the 3 times x plus 3 on the first term, and then minus 1/3, do it one more time, times 3 times x. Oh, I didn't do the same thing over there. On that one, all over, and just like we did before, leave it in factored form. 3x, I'm going to just rearrange them. X plus 3 on the bottom. All right, now when I go to simplify the top, notice that we have a common factor of x plus 3 and this x plus 3, which will cancel, right? That's the reason why we chose x plus 3 as being part of our least common denominator. Okay, wait. And likewise, on the second one, the factors of 3 will cancel out. All right, so let me simplify here. Limit x approaches 0 of, on the first one, we're just left with a 3. So 3 times 1, it's just a 3. Minus, and then on the second one, the 3's had cancel, it's just -1 times this. So I'll have to distribute that out. You're welcome to make that one step and distribute as you go. Or if you're, feeling some pressure, you can do it in a couple of different steps, but you just have to do it quickly. Bring down the bottom. Okay, does anything cancel? Hey, let me ask you a question. Does this cancel with that? No, it doesn't. When we cancel things, remember we only cancel common factors. Factors implies multiplication, and there's no multiplication going on up here, right? So we can't cancel these things out. I need to expand this out first and see if some like terms simplify for me. So I will have to distribute that negative sign through. I'm going to actually do that right up above here. So 3 minus x and then minus 3. And I can see that my 3's cancel. Limit as x goes to 0 of a negative x up top over 3x and then x plus 3. If your question is, could I have just canceled these x's out at this point? If you notice it, you can, for sure. I'm just trying to be as thorough as possible here. Now I can see that I have a common factor on the top and the bottom, which I can cancel out. What number does that leave up top? It's a 1. Actually, a negative 1, right, with that negative sign there. So one more time. Limit as x approaches 0 of negative 1 over 3 times x plus 3. Before I evaluate my limit, I do have a question for you. Hey, what's the relationship between this as a function and this one as a function? They are identical, except for this one doesn't have a hole at 0, and this one does. And this new one, the one that we just derived, fills the hole for me. And where's that hole at? I directly substitute in my 0. I get negative 1 over 3 times 0 plus 3. I believe we get negative 1/9. Put an official magenta box around that. And let's call up our graphing calculator. Let's get a little bit of confidence on this. Again, one of the things that we can always do when we're evaluating these limits, especially when we're first starting out, we're not quite sure about it, is let's just look at a table. Let's look at a graph, whatever. So I'm going to graph both of these, verify that, we did everything correctly. So our first function, I think, let's see if I can remember, y equals, and then I need some complex fraction going on here. So it's 1 plus, that isn't right, so apparently I didn't remember it, 1 divided by, and then I have the quantity x plus 3. Arrow out of that, and then minus a third. And then arrow out of all of that, and divide by, not multiply by, and x. There we go. Now it would be extraordinarily hard to see where that dot would be at 0, but does 1/9 make sense, or negative 1/9? It was negative 1/9? It was negative 1/9. It seems reasonable, right? It's pretty close to the x-axis right there. Let's graph the one that's supposedly equivalent to that one. Ooh, I wonder what color this one's going to be. It's exciting. Oh my gosh. All right, so I think it was a negative 1 up top and then divided by, and then on the bottom I had 3 parentheses x plus 3. Oh, it looks like it's going to be green. Boom. And again, I can just turn them on and off, and you can see that they are definitely equivalent, but one filled the hole and the other one did not. All right, so that concludes that particular question. In the next video, we're going to look at one more powerful strategy, which is called the squeeze theorem.